Exploring strange new worlds, understanding the origins of the universe, searching for life in the galaxy. These are not the plot of a new science fiction movie, but the mission objective of the James Webb Space Telescope, the long-awaited successor to the Hubble Space Telescope. Now that the telescope is finally operational, it has started making discoveries that are terrifying to scientists. Let's take a look at the newest discovery the observatory has made at the edge of the universe. When scientists planned and designed the Hubble Space Telescope, the most groundbreaking astronomical observatory of its era, there were many things about the universe they didn't know. One of these unknowns was that stars and galaxies existed already a few 100 million years after the Big Bang. But even if they had known about these early stars and galaxies, they didn't have the technology to make Hubble see them. By the time the Hubble telescope was built, it was clear that science had moved and changed in some areas which could not be explored by its instruments. It became obvious that another, even grander space observatory will be needed to get to those early stars and galaxies, those that had lit up the universe after hundreds of millions of years of darkness that followed the Big Bang, when the expanding space was only filled with hydrogen atoms. The technology that would eventually enable this observatory, now known as the James Webb Space Telescope, to see that mythical first light in the universe had yet to be developed. This missing piece of technology was infrared detectors that would be able to collect the faint light coming from those early stars and galaxies more than 13 billion light years away. Hubble was built to detect visible and ultraviolet light. These early galaxies do emit visible light, but because of their distance, the wavelength of this light gets stretched into the infrared part of the electromagnetic spectrum by the so-called redshift. In the 1980s, infrared pictures were taken with one detector scanning the sky 1 pixel at a time. The Near-Infrared Camera and Multi-Object Spectrometer, or NICMOS, the first infrared detector fitted on the Hubble Space Telescope during its second servicing mission in 1997. NICMOS, consisting of 3 infrared detectors, each of which had 256 by 256 pixels, opened the first door for Hubble into the infrared universe. The technology has come a long way since Hubble's early years, and the James Webb Space Telescope project has been pushing it further along the way. The detectors on jwst have 2000 by 2000 pixels. This will allow the new telescope's giant mirror to feed the light of stars and galaxies into 4 cutting-edge instruments designed not only to take images, but also to analyze the chemical composition of the near and distant universe. This is done with a technique known as spectroscopy, which looks at how matter in the universe absorbs light. As different chemical elements absorb light at different wavelengths, astronomers will be able to reconstruct what stars, nebulas, galaxies, and planets within James Webb Space Telescope's site are made of. These improvements in the resolution of infrared imaging are critical for imaging the furthest reaches of the universe, where the Hubble Space Telescope, or the recently retired infrared telescope Spitzer, could provide only a rough estimate of an ancient galaxy's age and chemical composition. Webb will deliver with precision. The most advanced instrument on the Hubble telescope was the Wide Field Camera 3. It allowed astronomers some of the best views into the early universe at the time. The James Webb Space Telescope is now positioned to surpass those accomplishments. When it comes to these distant galaxies, the Wide Field Camera 3 runs out of wavelength. This caused some of the detections made by the Hubble to be questionable, and now the JWST will be able to tell which ones turned out correct. Big stars form and die quickly, and the JWST will be able to detect them at greater accuracy. Many scientists are most interested in what happens when these early stars die, releasing their material into their surroundings to give birth to new stars. Astronomers know that the early universe had a very different chemical composition from what we see today. It consisted only of hydrogen, helium, and a little bit of lithium. All the other chemical elements that we see now, including those that make life possible, were cooked up throughout eons inside those stars. A lot of the chemical synthesis in the universe is around massive stars when they explode, or low-mass stars in their final stages of evolution. There's a lot of interesting chemistry that can happen in their atmospheres because of the temperatures and pressures. Studying this is of particular interest to astronomers, as it can explain how we can go from having only 3 chemical elements to the vast array of diversity we see in the universe today. The spectroscopes aboard the James Webb Space Telescope will be able to probe the chemical kitchens of those early galaxies, seeing what was cooking inside individual stars and what they fertilized the wider cosmos with when they exploded in powerful supernovas. Spectroscopy typically allows us to see this process on galactic scales, but with the JWST, scientists will have access to such a high resolution that they'll be able to view individual objects. While the James Webb Space Telescope and the Hubble Space Telescope are frequently compared, their images will be quite different, revealing different aspects of the universe. While Hubble's strength is imaging the visible universe, Webb's infrared superpowers enable the telescope to see through dust right into the heart of nebulas, galaxies, and star-forming regions that are hidden from Hubble's view. Scientists know that stars are being born in places like the Orion Nebula and other nebulae in the sky, but they couldn't see them in the optical because optical light gets absorbed by dust. Previous infrared observatories, such as NASA's Spitzer Space Telescope, were much smaller than Webb. Therefore, they couldn't see as far as Webb, and when they did, they only glimpsed those star-forming regions in a limited resolution. Previously, when we could see the site of star formation, we would see multiple objects all mushed in together. Webb will be able to separate them all individually. We'll be able to see multiple stars being born in clusters, where previously we could only detect those clusters. While astronomers have been able to map star formation in our galaxy, the Milky Way, the James Webb Space Telescope, will rip open star birth centers in farther away reaches of the universe. It will allow scientists to see more distant, extreme galaxies where the environmental conditions are very different from what we see in the Milky Way. But it will not all be about faraway places. Scientists interested in Earth's more local neighborhoods will also have their fun with Webb. The telescope will allow astronomers to look at planets like Mars, Jupiter, Saturn, Uranus, and Neptune, but also some that are further out into the Kuiper Belt. The Kuiper Belt is a repository of comets, asteroids, and other debris that encircles the outer solar system beyond the orbit of Neptune. It's a dark and cold region that is very difficult to explore because these objects reflect very little light. The instruments on board the JWST will allow for spectroscopy on the Kuiper Belt objects with far greater accuracy. These objects are really cold and don't reflect much light, so a big infrared telescope is needed to study them. Scientists know that they have ices and various molecules on their surface, and they hope that the telescope will allow them to see that. Just like with Hubble, science has moved forward since the conception of the James Webb Space Telescope, and new areas have emerged that may not have been foreseen when the first light machine was first conceived. In 1995, the first 2 planets orbiting another star, then our Sun, were discovered. Since then, thousands of exoplanets of various sizes and kinds have been detected. And while not designed with those potential other Earths in mind, the James Webb Space Telescope turns out to be positioned to not only discover many more, but also to tell us much finer details about their nature than any other mission before. One of the JWST's instruments, the near-infrared camera, is fitted with extra implements called coronagraphs, which block out the light of a star to see more clearly what is happening around it. That indeed might involve alien systems of planets, some of which might be habitable with water and an atmosphere that could support life just like Earth. The James Webb Space Telescope was built to revolutionize astronomy. 10 years from now, many of its most groundbreaking discoveries may come from realms that are still completely unknown today. This is because both the Hubble and Webb were built as general-purpose observatories. They were launched with some specific science goals, and they have a broad range of capabilities that enable them to make discoveries that were not in the areas they were designed for. Half of the greatest discoveries made by Hubble were things people had no idea about at the time. These include dark energy and exoplanet studies. Scientists firmly believe the same will be true for the JWST, and the discoveries it makes will change our view of the universe. One such discovery that the telescope is expected to make will tell us about the edge of the universe. Now that JWST is settled into orbit and sending back its first calibration images, we might as well ask, what will this instrument tell us about the past, and how does that even work? Characterizing a telescope as a time machine is both over and understating its abilities. The telescope itself doesn't travel through time, but what it does is much more profound than just giving us clues about the past. Telescopes peering out to distant reaches of the universe can see our cosmic history directly. The JWST can voyage back to the edge of time, not by actually going anywhere, but by sending us direct images of some of the earliest moments of the universe, showing us what it would have looked like if we had been there more than 13 billion years ago, watching the first galaxies form. It's able to do this partly because of the technology, which includes extraordinarily sensitive sensors and a 6.5 meter primary mirror, and partly because of this one weird trick enabled by Einstein's relativity. One of the foundational principles of relativity is that everything you see is in the past. There's nothing special about telescopes in that regard. It is, in fact, impossible to see the present moment at all. Because light takes time to travel, the image you see of a distant thing has already aged by the time it's reached you. You're seeing the thing as it was sometime in the past. It's not noticeable in daily life because light speed is so fast that when you look at something on the other side of the room, it's only a handful of nanoseconds in the past, from your perspective. But a space telescope can see distant stars whose light has been traveling for hundreds or thousands of years, and galaxies so far away, we're seeing them as they were billions of years ago. With the Hubble Space Telescope, we've already been able to watch galaxies shine and stars explode within the first billion years after the Big Bang itself. The JWST will go a factor of 100 times deeper than any existing images we have using ground-based telescopes or Hubble. This is a massive gain in sensitivity, which will allow scientists to increase the number of early universe galaxies known by factors of 100. Soon, we'll be able to see more than just the brightest and rarest representatives of the first generation of galaxies. With JWST, we'll be watching the very first collections of stars coming together all across the cosmos, lighting up their surroundings and setting the stage for the vast and varied universe we see around us today. Astronomers hope that the JWST will finally answer some of our most pressing questions about the origins of structure in the universe. Still curious about the James Webb Space Telescope? Please consider checking out this video, which talks about 5 discoveries the JWST is expected to make. Do you think the JWST will eventually find a new habitable planet? Please share your thoughts in the comments section below.